Good evening, everyone. I hope I'm audible.
Good evening, ma'am.
Very good evening. I hope we can start now. So, distinguished delegates, ladies and gentlemen, namaste to all of you. On behalf of Deshbandhu College, University of Delhi, and our conference team, I welcome all of you to this virtual room in Zoom Meet and to this international conference on integrative chemical science for health and environment. As we are going to start this oral presentation session, so we in this room have 13 oral presentations in total. In scanning the program list, or we can say the program of this international conference room, one is immediately impressed by the wealth of expertise you all represent and the spectrum of important issues covered by the papers you will be presenting. The subjects range from descriptions of synthesis of nanomaterials, their theoretical studies, scale-up developments, and applications in health and environment with new developments. I'm sure that the selected topics will provide you with a wealth of information and many opportunities for discussions. I would like to express my sincere gratitude to Dr. Darshan for agreeing to chair this session. Dr. Darshan is currently working as Associate Professor in the Department of Chemistry in Daulat Ram College, University of Delhi. Dr. Darshan has done her PhD from IP University and Masters from University of Delhi. Her specialization is in nanotechnology, polymers, and organic synthesis. She has a rich teaching and research experience of about 18 years with 20 research publications and more than 30 research presentations. We can also find 3 books and 3 chapters published under her name. Welcome, Dr. Darshan. Before proceeding, let's go through a bit of timing rules. We request you to wind up your presentation in 7 minutes, and we will keep 2 or 3 minutes for discussion or question and answer sessions. Thank you. So without further delay, I'm handing over this session to Dr. Darshan. Over to you, ma'am.
Thank you so much, Archana. I think we should already, it is the 4:30 and we should begin with the program. So can we call the first person to present his or her work?
So,
Archana, I hope you are going to announce the name or the number only, like the oral presentation number. I think the number will work. 38, like I have to, see the presentation from 38, no, right?
Yes, ma'am.
So you can call by number.
OV38, that is Pushpa, Miss Pushpa M. Is she there?
Yes, ma'am. Yes, ma'am. I'm here.
Yes. Please share your screen, Pushpa.
Ma'am?
Yes.
Can I start, ma'am?
Yes, you can start. Please share your screen.
I have shared, ma'am.
Somehow.
I think you have to make her a host, only then she can be able to present her screen. Please make all the participants co-host.
I think so. Permission is granted to everyone.
Let me check. No, it's not so. They are only participants. No permission has been given to them. That is why she is not able to present her work.
Pushpa, please try it once again.
Is it sharing my
Is,
ma'am?
Yes,
it's
it is
visible.
visible.
Okay, ma'am. Good afternoon to all. I am Pushpa, the research scholar, the Department of Studies in Chemistry, Davangere University, Davangere, Karnataka State. It's my pleasure to present the presentation on the topic green synthesis of silver nanoparticles from Clitoria ternatia plant extract and their application in antibacterial activity and electrochemical studies. So, these are the contents involved in this presentation. Let me start with the introduction. Nowadays, the most popular and most trendy technology for the synthesis of metal and metal oxide nanoparticles from various plant extracts is green synthesis. Green synthesis employs a clean, safe, cost-effective, and environmentally friendly technology for the construction of nanomaterials. So this presentation provides some detailed information about the synthesis, characterization, and application towards antimicrobial activities of silver nanoparticles that are produced by using the medicinal plant Clitoria ternatia. And in forthcoming days, we are going to study their detailed electrochemical applications. So this is the general method used for the synthesis of nanoparticles by using plant extracts. So the whatever the material we chosen for the synthesis is a medicinal plant which contains various phytochemicals and secondary metabolites like phenolic compounds, tannins, flavonoids, alkaloids, terpenoids, etc. And those secondary metabolites will play a role as a both reducing agent and a stabilizing agent for the synthesis of nanoparticles, silver nanoparticles, by reducing Ag plus ions into zero valent silver nanoparticles. So the synthesis of silver nanoparticle involves two steps. In the step one, we are going to prepare the plant extract. This is the plant we chosen for synthesis, and its classification is given as follows. Its botanical name is Clitoria ternatia and its common name is butterfly or Shankhapushpa. It belongs to family Fabaceae and subfamily Faboideae and genus Clitoria, species ternatia. Because of its medicinal properties, it is used in the field of medicine. So the workflow we used for the green synthesis of silver nanoparticle by this plant is given in this graphical abstract. The fresh leaves of Clitoria ternatia were collected in the local region of Davangere, and the leaves were washed in the running tap water and followed by distilled water, and those were cut into small pieces and crushed in a mortar to make a paste. To that we add 100 ml distilled water, and that solution was heated on a magnetic stirrer for about 1 hour at 60 degrees Celsius. So after stirring, the solution was filtered using Whatman #1 filter paper, and the obtained plant extract is added to the freshly prepared metal precursor, that is silver nitrate, for about 30 minutes on a magnetic stirrer at 60 degrees Celsius. The formation of silver nanoparticle is indicated by the color change in the solution. So the color change is shown in this figure. This is the silver nitrate, colorless silver nitrate solution, and this is second figure B indicates the plant extract. By adding these two, we get the dark brown colored solution, which indicates the formation of silver nanoparticles. And that solution was filtered using Whatman #1 filter paper and dried at room temperature and kept in desiccator for the complete removal of moisture that is present in our nanoparticle. And the obtained nanoparticles were subjected to many characterization techniques. We used UV visible spectroscopy, FTIR spectroscopy, and X-ray diffraction technique for the characterization. Coming to the UV visible spectroscopic analysis, this is the spectra we obtained. The UV visible spectrum between 200 to 800 nanometer range is used for the prediction of synthesizer silver nanoparticles. The surface plasmoresonance of the synthesizer silver nanoparticles is indicated by the absorption band at 458.35 nanometer. And the UV visible spectrum is plotted by taking wavelength in nanometer along x-axis and absorbance in atomic unit along y-axis. FTIR spectral analysis. For effective stability and accountability in the metal nanoparticles, FTIR spectroscopic technique is performed or investigated to determine the functional groups present in the phytochemicals, potential biomolecules in the plant extract. As I mentioned earlier, the leaves of Clitoria ternatia contains various phytochemicals which serves as an highly active components during the interaction with the metal precursor, silver nitrate, to produce silver nanoparticles. So the peak at 3671.48 per centimeter shows the presence of alcoholic OH stretching vibration due to the presence of phytochemical. And these two peaks around 3000 shows the presence of unsaturated and saturated systems respectively. The presence of aromatic ring is indicated by the peak at 1403.64 per centimeter, and presence of carbonyl stretching and alkene stretching bending vibrations, both peaks at 893 and 439. Coming to the XRD analysis, the XRD pattern of the synthesized silver nanoparticles was recorded by using X-ray diffractometer with copper K alpha radiation, which has the wavelength about 1.54 Armstrong. And it is used for the confirmation of the crystallinity and nanostructure of the synthesized silver nanoparticles. And an instrument is operated under optimal conditions of voltage about 40 kilovolts and current 40 milliammeters. So the diffracted intensities with angle of 2 theta. Excuse me, sir. Hello.
This at 1952 H. This at the rate 1952.
Sir.
Please continue, Pushpa.
बस इसमें से ग्रुप पे हो आप? कौन से ग्रुप पे हो? ऑनलाइन आईटी आईसीची टीम वाले पे हो? अरे वो लिस्ट इसी मेरे वाले ग्रुप में भेज दो ना, आईटी वाले सब देख लेंगे.
Excuse me, ma'am.
Archana, Dr. Archana, are you there?
Yes, I have means
Please,
I have
please,
spoken
please.
to them, please.
Yeah, please, Dr. Raju, please tell him. Yeah, beta, continue.
Okay, ma'am. The diffracted intensities with angle of 2 theta were recorded by giving 4 different peaks of silver at 38 degree, 44 degree, 64 degree, and 78 degree, which corresponds with the lattice planes of face-centered cubic structures of silver at 111, 200, 220, and 311. So this is consistent with a number of publications that reported XRD patterns of biosynthesized silver nanoparticles with similar properties. And coming to the applications towards antimicrobial activity of synthesized silver nanoparticles, we use agar-well diffusion method. The gram-positive bacteria, Staphylococcus aureus, and the gram-negative bacteria, E. coli, were subjected to evaluate the antibacterial efficacy of the silver nanoparticles that are synthesized by using Clitoria ternatia plant extract. The agar-well diffusion method is used to measure the zone of inhibition that is exhibited by the silver nanoparticles that we synthesized. The result of zone of inhibition study reveals that the silver nanoparticles possess antimicrobial activity in a concentration-dependent manner. As we increase the concentration of silver nanoparticles, we get the better results. Like that, Staphylococcus aureus did not show any inhibition zone at higher concentration also. So E. coli shows the best results as the concentration of silver nitrate, silver nanoparticles increased. So this is the table we obtained. So coming to the conclusion, so green technology, green synthesis is the best way to produce silver, any kind of nanomaterials or nanoparticles that are used for the application towards antimicrobial activity. And from our study, we conclude that the higher concentration of silver nanoparticles shows an effective zone of inhibition towards the gram-negative bacteria E. coli. Thank you. Thank you, madam.
Pushpa,
Ma'am.
I have a question.
Yes, ma'am.
Beta, how did you confirm that the antibacterial activity which is coming, that is coming because of silver nanoparticles which you have synthesized, not because of the silver metal?
Yes, ma'am. Ma'am, silver nanoparticles were combined with standard drug ciprofloxacin, ma'am. That's how we differentiate the zone of inhibition that is exhibited by the two different bacteria.
That I have seen, the E. coli and the one more bacteria, the
Staphylococcus
gram
aureus.
positive and yes, bacteria, gram positive and the gram negative bacteria. But I'm asking,
Yes,
Beta,
ma'am.
how did you confirm that it is coming only because of the silver nanoparticle, not because of the silver ions? You know, the silver is a known antibacterial agent.
Age.
Yes, I just want to know it is not coming because of the silver ion or it is coming because of only silver nanoparticles.
Yes, ma'am.
How to ensure that?
Interaction between
The
the
one more thing, Beta, one more thing, because since you have taken the medicinal plant, so it might be having some property of antimicrobial
Yes, ma'am.
property. So have you checked the antibacterial or property for that plant extract also?
Plant extract. No,
Yes.
ma'am, we didn't perform that.
I think you should, because for the comparison that the whatever property is coming, it is coming because
Yes,
of
ma'am.
nanoparticles which you have synthesized. So this should be a reference of the silver nitrate solution. There should
And
be a reference of the plant extract to have
yes.
a comparison, the better comparison.
Okay, ma'am. Okay, ma'am.
And only one you have taken the ciprofloxacin,
Yes,
right?
ma'am. Ciprofloxacin.
Okay, fine. ठीक है.
Okay.
Thank you, beta.
Thank you, ma'am. Thank you, ma'am.
So, okay, our participant is Maria Sundriji. Are you there?
Yes, ma'am.
Please share your
Oral presentation number 39.
Yes, yes.
Thank you.
I am present. Share screen. Then, very good to respected the day. Ma'am, am I audible?
Your voice is breaking and your screen is also not visible, Maria.
Yes, ma'am.
I request the rest of the participants, please be ready with their presentation.
Can you hear me? Ma'am, am I audible?
Yes, you are audible, Bache.
Ma'am, can I?
Yes, screen is also visible, but you can presentation. It's Zoom screen.
Sit up. Ma'am, can I proceed?
But click on the PPT, the power. Yeah, now it is visible. You can put it on slideshow and start.
Yes. Okay, ma'am. Good evening, ma'am. I am Maria Sundari from Geetam University, Visakhapatnam. I'm doing my research under the guidance of Professor Anchaleja. And my work is green synthesis of benzoxazolone and thiazolone analogs and their DFT studies. As we know, my work is based on the green synthesis.
Maria, your screen is not
As
visible.
all know,
Maria, your
is one
screen
of
is not
the
visible.
best method for preparation of, also to study biological we can contribute to society. And ma'am,
Sorry to
Maria,
interrupt, Maria. Your screen is not visible.
it is
Your screen is not
you see
visible.
my
I think the
screen.
cursor is still on your Zoom screen.
Ma'am, it is already.
Yeah, please. Just take care of your cursor. Okay, put it on slideshow, beta. Maria, put it on slideshow. There's a cup icon on the right hand side.
Yes.
Click on that, or the F5 if you can press.
Is it okay, ma'am?
Yeah, please proceed, Maria.
Ma'am,
Yeah, it is okay. You can proceed. You can proceed.
yeah. I mean, aims and objectives of this work. My aim is to prepare. I have prepared the content of benzoxazolone and benzolone, and the objectives are to specify and give importance to the green synthesis of this preparation of the compound to structural mass, and then confirm the new products are being formed. And that the object is to comparative studies between two methods that I used. One is conventional method and the other is the ultrasonication method, and to specific ultrasonication method which is synthesis method better than the conventional method. And our fourth object is to study the biological activities of these newly found through antimicrobial antibacterial studies. And the method used are one is ultrasonic method and the another is a conventional method. First scheme tells the starting material of this preparation by taking orthomino and urea as well as orthomino thiophenol with the first starting material the code numbers given them are prepared by using conventional method as well as the sonication method. That P1 start material is prepared benzoxazolone with semicarbazate with thiosemicarbazate. Second starting materials called P2 and P8 are prepared. And later help to prepare series of compounds for preparation of the benzoxazolone as well as benzodioxazolone, where I have taken 4-hydroxybenzoaldehyde, oxybenzoaldehyde, 2,5 dimethoxybenzoaldehyde as a reactants along with P2 as well as P8 in order to pair the series of 12 compounds. This the given diagram show only the first series is P1 series, and similarly the other partners P7 series compounds are also prepared. Totally 12 compounds are being prepared. Compounds. So here, kinetics of the sized compounds through conventional method as well as the
Excuse
ultrasonication
me,
method,
Vijay.
where we can see time taken.
The slide, please
Ma'am.
come to your PowerPoint slideshow. Once again, the screen has turned back to the Zoom meeting. Please take care of your cursor.
For me, is that now?
Means your screen is visible, but it's Zoom meeting screen rather than your PowerPoint presentation.
Ma'am,
Better click on the PowerPoint icon. Can you see the bottom one, the PP
yeah,
in between the two
I-
Google icons? Please click on that. Click on that. We can't see your slides, Peter.
Yes, now click on yes. Click on this. Aim and object. Yes.
it is gone, and then
Better skip this slide. Just come to your work.
ma'am. Now I am in reactionetics of synthesized compound. Can you see, ma'am?
No, beta, it's not visible. Move to the next slide.
Can I proceed, ma'am?
Nothing is visible beta on the screen. Maria, okay, you are starting your screen sharing again. It's buffering. I think some network connectivity issue is there.
Vishwanath,
Ma'am, I'm sorry for the inconvenience.
Can you summarize
The
your
next
works without showing your
person.
screen? If it is not coming, this issue is there. We would like to hear what you have done.
Okay, ma'am. Yes, ma'am. Yes, ma'am. Thank you for giving me the chance. So, the composer prepares a functional method as well as the ultrasonic method, and in the conventional method, it's taking hours to the reaction, whereas in the ultrasonic method, it's hour, the hour, or in minutes, like 30 minutes, 40 minutes takes. The yield also is comparatively high for ultrasonication method. And I have the graphical representation, which now you are unable to see. And then compounds are all, the newly formed compounds are being confirmed through IR, NMR, and mass. And only few compounds I got for the sake of this oral presentation, and the other compounds are given for that. And in that, I have taken shown the P8 compounds, NR, proton NMR, where the peaks at 4, 7, and 8 ppm gives the presence of nitrogen, as well as the peaks at 5, 6.98, 7.41, and 7.82 shows the aromatic present in the benzene ring of the newly formed compounds. So I have confirming that the new product is found. I have for further studies, ma'am. Actually, this is my ongoing work. So now I am doing my antimicrobial biological studies of this newly formed compounds laboratory. So coming to the result, and here the given to the preparation method, so communication method, preparations and taken. I can alteration method is much better to prepare these compounds than the conventional method. And I have also gone for molecular DFT studies, in which I'm trying to study the structure of the electronic structure of the compounds, and then proceed for docking studies in order to know the energy of these compounds, so that we can synthesize in more amounts for and contribution of new drugs. So now I'm also doing the docking study for this compound. Thank you, ma'am. My
Okay,
work
Maria.
is still on process. I'm
Yeah,
sorry, ma'am, for the
no, it's
inconvenience.
okay. It's okay. It's not your fault. It's a network problem. Uh,
Yes,
Maria, Nikki, how would you say that your method is better, and what is the novelty in your work?
ma'am. Actually, the theme, the central point of my work is the green synthesis. In that, there are many methods
How
in
would you
which I
say
have.
that? Nibita, how would you say that it is a green? This is the only method which is a green method. I think
No,
there are so
no,
many
there are
methods
other
are reported in
methods.
the literature by which you can synthesize. There are
My
many senses. Okay, in
Yes,
what senses you are saying it is green?
because there is not much. It is also a solvent friendly. Not much various solvents are used. Only ethanol is used, and also we have got the product in good yield. All that
Okay,
is there, ma'am.
atom
Time.
economy. Okay, so
Yes,
atom economy. Okay, and the
ma'am.
solvent less. So these are 2 points. How many principles are there in the green chemistry,
12
Maria?
principles are there, ma'am.
Okay, so in your method, the 2 principles have been used.
Ma'am, pardon?
You are focusing on the 2 principles of green chemistry. The one is the atom economy and the second one is the solventless, right? Is
Yes,
there
ma'am.
any other principle which you have used in this?
Yes, ma'am.
What?
Time saving, ma'am.
Time saving. Okay. Okay. Thank you, ma'am.
Yes.
Next.
Thank
The ma'am, I have sent you the evaluation sheet as well, if you have received.
Yeah,
some.
I have received that. I'm doing that.
Okay, thank you. Thank you.
Uh,
Now, next one is Amit Bharadwaji. Are you here?
Yes, ma'am. Yes, ma'am. Good afternoon.
Please share your screen.
can you stop sharing, Maria? Only then the Amit can share his screen. Please start your presentation, Amit.
Yes, ma'am. Ma'am, can you share my PPT? I can send WhatsApp because I don't know how I can share. Are you sure, ma'am? Yes.
Yes, screen is visible.
Yes, ma'am. Ma'am, good afternoon to all of you. All of you, sir, ma'am. My name is Amit Bharadwaj. I am presenting as internal conference abstract on basis of the green cells of battery nanoparticle, bimetallic nanoparticle for the photovoltaic degradations application under supervision of Dr. A.K. Singh as the assistant professor in MME Mutambala. My contents is introductions and synthesis method, synthesis of biometric nanoparticles, result and calculations, photocatalytic application of nanoparticles, and conclusions.
Amit, present your work only. Skip
Okay.
introduction.
Ma'am, I am present. Firstly, I am shortly talk about the methods because this method chosen by the so importance of this because plant medical synthesis approach is a better method for the nanoparticle synthesis in comparison to the other methods, since it is eco-friendly, simple method, and avoid the environment as well as generation of toxic chemical as by the byproduct during the synthesis. While other methods are costly for implementation, energetic consumption, beside and the toxicity of the employed chemical synthesis required special equipment and reagent for the synthesis of nanoparticles. I'm preparing the nanoparticles of bimetallic iron cerium bimetallic nanoparticles. This is magnetic nanoparticles in which I have used the plant of curry patta, means curry leaves. This botanical name is Moria carangi. And this has the chemical constraint is usually this chemical constraint is very important for the synthesis of nanoparticle because it have the stabilizing and capping agent after analyzing the synthesis. Firstly, I have take the leaf of curry leaves and wash, and after dry and crush after the crush of condense of this crush particle in distilled water of 4 to 5 hours, and then filter the extracts, and this filter extracts in pour the two salt of cerium nitrate and ferric chlorides and mix together and hitting on the manganese stirrer for up to dryness, and after dryness the paste taken in crucibles, and this crucible take for 2 hours in open furnace for 500 degrees centigrade and 4 to 500 degrees centigrade, and then wash the material by distilled water and ethanols 4 to 5 times. And after use this powder materials for characterizations, and we have used the first characterization FSME, force emission scan electron microscopies in IIT Roorkee. This characterization information give the nanoparticle act as a potential capping agent for the prevention of nanoparticle agglomerations. And after analyzing the EDS, this instrument analyze the composition of the nanoparticle present in the materials. 28.13% of iron and 37.37% of cerium and 21.44 oxygens present in the materials, and combined with form in the carbon are present with oxygens, cerium, and irons. Another method another characterization by TGA. TGA indicated by the stability of how much the stability of nanoparticle, in which 6% of the 6% of material are weight loss at 800 centigrade, and decay of the organic bond in between of 6%. Each decomposition of the sample during the nanoparticle synthesized from curry leaves. And after the application of this nanoparticle used for by the degradation of dye by in sunlights. Some experiments are done in the labs. Biometric nanoparticle, I have prepared the sample of 5 ppm and pH maintained the 9s, and dose changed by the 25, 50, and 50, 75, and 100. Constant concentration of dye, constant pH, and different concentration of dose of nanoparticles. You can see the degradation of dye in different stages of 30 minutes, 60 minutes, 90 minutes, 120 minutes, 135 minutes. And again, we change the pH, and dye's concentration is fixed and dose is changed 25, 50, and 75 or 100. Again, we prepare the methyl blue dyes of 10 ppm solutions, and dose changes of 25, 50, and different pH, same pH and same concentration of dye, but dose is different. But we can see that the color of the sample of change because this color show that the degradation of dye in different doses. Conclusions: many researchers have used curry leaves plant part extract to synthesize biometallic nanoparticle from source compound by the green and economical routes. Various cytochemicals present in the curry leaves act as a both reducing and capping agent for the both synthesizing and stabilizing nanoparticle of selected material. Most of these biometallic nanoparticle synthesis have been put to possess significant application in any scientific domains. Thank you.
Amit,
Yes, ma'am.
yeah. You have characterized your sample on the basis of FESM, right? DAX.
Yes, ma'am. Yes, ma'am.
And the one more XRD, I think you have not taken, right?
I have
Only two
characterized-
characterization techniques
Ma'am,
you have used.
ma'am,
FESM,
I
DAX,
I
and
have
the FESM.
FESM, ATS, and TZ.
ATS. Can you show me that ATS which you said?
ADS, ma'am. ADS and
हाँ, ADS,
FESM.
वही तो मैं
Yes.
कह रही हूँ ना, energy
And
dispersive
on
scanning and the
TZ.
thermo-TGA, right?
Yes, sir.
That is
Yes.
that is the weight loss, na? कि how much
Yes.
is the stability of the
Stability of
sample.
the nanoparticle. Yes, sir.
Yeah. Okay, you have studied your, the application of your sample as in photocatalyst. Okay, so
Yes, sir.
these metals are the nanoparticles are acting as a photocatalyst towards the methylene blue. What is the lambda max for the methylene blue? And how did you confirm that the dye is degrading? That they are acting as a catalyst, the photocatalyst, just on the
Ma'am,
basis of the color fade, the fading of the color, or something you have done? How you
Ma'am,
how did you analyze that degradation, photo degradation of dye?
yes, ma'am. I am some characterize and give the information about this because I will not because I have in working conditions, so
The
I
UV
can
spec
don't.
have recorded
Yes, ma'am.
660
Yes,
nanometer. Huh?
yes, ma'am. Yes, ma'am.
660 nanometer.
Yes, ma'am.
Okay, and how much time it took? The 2.5, right?
Yes, 135 minutes total.
That depends upon the quantity of the nanoparticles which you. Okay,
Yes, ma'am.
as you increase the quantity,
Yes.
degradation increased. Okay,
Yes,
so
yes, ma'am.
initially, it
Yes,
was
ma'am.
taking like. I think you should study the photo degradation towards other dyes also, like the rhodamine B and some other.
Yes, I'm in queue of other dye of orange acid orange 7.
And you must also introduce some characterization technique like the temp, the what is the size of the nano.
Ma'am, it is in process. I have given the sample in Delhi, and the accreditation are not coming.
Because the size is very important, right?
Yes, ma'am. Yes,
And the
ma'am.
DLS also you should go for that. And I think the photoluminescence property you should study because you are saying they are the what you said कि iron है ना ये आपके magnetic nanoparticles you also said ना.
Yes, ma'am. Iron is present in magnetic.
The iron is present in the magnetic nanoparticle. I think some more studies should use in this. Okay, Amit, thank you.
Yeah.
Next,
Thank you, ma'am.
can we have the next?
The next participant is Bitokali Zimomiji. Are you here? Mr. Amit, please unshare your screen.
Okay.
Bitokali Zimomi, are you here? I can see your name in my chat room. Are you here?
Yes, she's here.
Yes,
She's
ma'am.
here.
I just muted.
Okay.
It's my scribble, ma'am.
Yes.
It's visible.
Okay. Good afternoon, everyone. Respected person, ma'am, faculty, and scholars. My name is Beto Khalif. I'm a research scholar from the Department of Chemistry, Nagaland University, and I'm going to present my paper on tidal wave assisted synthesis of 1,4-oxazenes and their evaluation as antibacterial agents. So, as an organic chemist, I'm inclined towards
But your slide is not
the studies.
visible. Basically, your slide is not visible.
I'm sorry, visible now, ma'am? Okay. So my title of my paper is Microwave Assisted Synthesis of 1,4-oxazenes and the Evaluation as Antibacterial Agents. So I'm interested in synthesis of heterocyclic compounds. So heterocycles are basically ring systems in which addition to the carbon and hydrogens, there are present nitrogen, sulfur, and oxygen. Oxygen is one such 6-membered heterocyclic compound which comprise of an oxygen and a nitrogen as heteroatoms. So depending on the position of the oxygen and nitrogen, oxygens can be classified into 1,2-oxazine, 1,3-oxazine, and 1,4-oxazine. This work is based on the synthesis of 1,4-oxazine. So figure shows biologically active benzoxazine derivatives which are already in use as drugs. The first one is levofloxacin, which is an antibiotic for the treatment of pneumonia, bronchitis, CT, and other skin infections. And another example is favirenz, which is an anti-HIV, which shows HIV activity. It is sold under the name Sustiva, and among others is an antiretroviral medication used to treat and prevent HIV/AIDS. So, thus indicating showing the importance of oxazine derivatives. And oxazines being flexible compounds can be manipulated to design diverse range of drug compounds. The early activity of oxazine derivatives were biological activity was shown reported by Novelli and Dams as early 1937, and 1,4-oxazines are now reported to be antifungal, antibacterial, and anti-tumor agents, and they are also reported to be analgesic and antiviral, anti-inflammatory, etc. And besides this, their importance in the pharmacological and biological are also dates in the synthesis of larger heterocyclic compounds and polymers. So, keeping in mind the importance of oxazines, I chose 1,4-oxazines to study and evaluate its antibacterial properties. This shows the trends in synthesis of 1,4-oxazines, showing the variation in the starting materials. Over the years, more and more variations in the starting materials have shown, and it has increased, and more importance has been given to green chemistry methods. So one of the first were starting materials were nitrosol, naphthol, ethyl bromoacetate, and over the years, aminophenol bromide were used for the synthesis of 1,4-oxazines. So my objective is to synthesize and characterize 1,4-oxazine derivatives and evaluate their antibacterial activities. A series of 1,4-oxazine derivatives were synthesized by conventional as well as microwave-assisted method, and comparison was done. In the first method, 1 mole each of the substituted aminophenols and phenacyl bromide, along with the cesium carbonate base and the catalyst DMP, which is dimethylaminoperidine, were used for the and in presence of 10 ml ethanol. By thermal method, reflux was used, and the reaction reflux for 5 to 10 hours. The completion of reaction was monitored by TLC, that is chromatography, and the product was isolated by crystallization. And for some products, column chromatography was used with ethyl acetate and hexane as solvent system. The second method was microwave irradiation reaction. It was assisted by microwave irradiation. The starting materials, along with the catalyst and base, were taken in a brass test tube and irradiated in microwave digester. We used Anton Par Monowave 400. The reaction took only 3 to 5 minutes at 120 degrees Celsius. The reaction was solventless as compared to the thermal method. The product was isolated. Melting points were taken for the different compounds, and characterization was done using different analytical techniques such as FTIR, IR spectroscopy, mass spectroscopy, and proton and carbon spectroscopy. Figure 2 shows the graphical illustration of the methodology of the synthetic protocol, and the first table shows the list of synthesized products. Altogether, 11 different products or compounds, 1,4-oxazine were synthesized. I used three different types of aminophenols, 3 substituted aminophenols, and 4 different types of phenacyl bromide. The compound 3D and compound 3H gave the highest yield. The significant decrease in reaction time was observed for microwave-assisted reaction as compared to the thermal reaction, and the yield was also significantly higher, hence proving the efficiency of the microwave irradiation reaction. And the synthesized products were confirmed and characterized by different analytical techniques. This is a representative spectral data of the compounds 3B and 3D. This is a representative spectra of compound B and D, mass spectra. Continuous development is seen in discovering novel antimicrobial agents, and despite oxazines being greatly studied agents, no report on the antibacterial studies on the presently synthesized compounds were found in literature. Hence, they were assessed against selected human pathogens. The synthesized compounds 3A to 3K were screened for the in vitro antibacterial activity by using agar-disc diffusion method against 4 strains of bacteria, 4 gram-negative bacteria and 2 gram-negative bacteria and 2 gram-positive bacteria. The plates were inoculated with a liquid culture of the test organism, and this containing antimicrobial agents, that is the synthesized compounds, were placed on the surface and incubated for 24 hours. The test organisms show susceptibility to the synthesized compounds indicated by the inhibition of bacterial growth around the disc, zone of inhibition as recorded in the table. Neutron agar was employed as culture medium, and DMSO was used as solvent control, and streptomycin was used as standard control for antibacterial activity. The compounds 3B and 3H shows shows the most inhibition zone. Figure 5 shows the prominent zone of inhibition observed by the synthesized compounds against the bacterial strains. The first column shows the inhibition by compound 3A and 3J against Staphylococcus aureus. The second column shows inhibition against Klebsiella pneumonia. The third shows the zone of inhibition of compound 3H and 3J against Bacillus subtilis, and the fourth column shows inhibition against E. coli. So also the minimum inhibitory concentrations were determined by means of standard 2-fold serial Booth dilution method. 2 mg per ml of DMSO concentration was used, and streptomycin was used as positive control. It corresponded to the minimum inhibition zone of inhibition, and compound 3B and 3C showed the most minimum inhibition concentration, and compound 3H also showed low minimum inhibition concentration, and 3K also showed very less minimum inhibition concentration. That means the very least amount of the synthesized compounds were used. So in conclusion, a simple and efficient microbial acetate protocol is reported for the synthesis of 2H-benzo-1,4-oxazine derivatives using DMAP as catalyst, which shows advantages over the thermal method, that is the reflux method, in terms of the following: shorter reaction time and higher yield, and also by the reaction condition was neat, that is less solvent was used, and the synthesized products were tested against 4 bacteria, and they were shown to have good antibacterial activity. Thus, the future direction for this work is to improve the catalyst and more working conditions, and to optimize the yield in more efficient, environmentally friendly way. And more efforts can be given for the complete removal of dependence on the solvent, other toxic, expensive catalysts. These are some of the references I used in the presentation. Thank you. If you have any questions.
Basically, I have a question. The which microwave? Is it domestic or the commercial microwave you have used for the synthesis?
It was the commercial microwave, ma'am. It was a monowave, Anton Par monowave 400 microwave digester, specifically for chemical reactions, ma'am.
Okay. And what is the novelty? That is the minimum time and the solventness. These are the two things.
Yes, ma'am. Very minimum, very decrease
I
in
think
the
3 minutes. I think
chemicals, yes, and
4 minutes,
and
right?
yes, there was drastic change in the reaction time, and also the solventless, and also no other reports were done on the antibacterial activity of this specific compound.
Okay. Disk diffusion method you have used, and after 24 hours, you have taken the result. You have analyzed the zone of inhibitory zone.
Yes,
okay.
ma'am.
Okay. What about after 48 hours?
It did not change, ma'am. That's why
Okay.
it was the same. That's why
Okay.
I added only 24 hours.
Thank you, Beta. Next.
The next presentation is OV42 by Minuji. Minu, are you here? Yes.
Hello, am I audible?
Yes, you can start.
A very good evening to everyone. I would like to thank Deshbandhu College for providing me this opportunity to present in front of you all. And again, I would like to thank Dr. Darshan for giving so much time for this presentation. Is my screen visible?
Yes, Beta.
Okay, so my topic for today's presentation is sustainable biomass development for the scale-up of biofuels and bioenergy. So this will be my content for the today's presentation. So if the for the today's, as we are in 21st century, the population is increasing day by day, and it's increasing continuously. So if population increases, what are the basic requirements? So first of all is the food requirement, and second is the energy to meet the needs. As the food requirement increases, the soil nutrient values are decreasing. Increasing food demands results in the need of nutrients in the soil. Additionally, the availability of the fossil fuels is steadily declining, leaving a large deficit for the future generation. So these are the basic requirements for the today's generation. So for that, how do we meet the demands and how can we do that and what will the material? So biomass contain two words, bio plus mass. Bio is easily degradable, hence they are of no use to the society, so we are degrading it. As we can see in Delhi during winter times, when a lot of pollution is created due to the parali burn in Punjab and Haryana region. So it's for no use for the farmers, so they are burning, causing a lot of pollution to the environment. So to curb that problem, so we need an alternative which can provide nutrients to the food, plus it can be converted to the energy requirements. So how the techniques, how biomass can be created to a useful products. Bio waste, it's of no use. So bio waste for basically biomass contain three compounds: lignin compound, cellulose compound, and hemicellulose compound, but of waters and some microbes in them. So kind of bio waste are very necessary because they are of large scale. So first, crushing, grinding, and drying are the most required step for that. After which it is a biomass. There are several types of biomass: wet biomass, starch containing biomass, oil seed biomass, cellulose biomass. So oil seed biomass can be converted to bio oils and then to bio diesels. Now, cellulose biomass can be treated in the two ways, that is thermochemical processes and biochemical processes. In thermochemical processes, heat provided to degrade the material to yield some useful products. And second is biochemical process, that is fermentation, aerobic digester, and non-aerobic digesters. In that thermochemical process, the most focused in nowadays is pyrolysis, because it can be converted into 3 to 4 products, that is biochar, pyrolytic oil, syngases, and heat. Biochar uh, word is comprised of two words, that is bio and char. Which is easily degradable, and char is the compound that contain a high number of carbons. So there are several factors which affect the biomasses. Number one is the feed strokes. Different biochars and biomasses have their different composition and different water content in that. So the feed strokes plays an important role for the products to be synthesized. Second, for biomass or biochar, pH of the soil, because the soil in which we are supplying, generally biochars are have a higher pH of around 9, varying from 9 to 11 pH. So the pH of the soil in which the soil we are degrading, it's have a very high importance in that. Third one is pH of the material. If we are agglomerating the resultant biochar with something, so the pH of that material also plays the important role, the initial biomass sample. Fourth is pyrolysis temperature. While creating a product, the temperature we are varying. Generally, for the pacha productions, it's varying from 300 degrees Celsius to around 1200 degrees Celsius. So that temperature plays a major roles, because lots of chemical bonds get degraded or get breakdown during with the. Third is pyrolysis of feed soak. Pyrolysis of feed soak yields in the three products. So depending upon the product which we want to yield, that is biochar, bio oil, and syngas, the pyrolysis of feed stock temperature range should be varied. Fourth is the environment of pyrolysis. Generally, pyrolysis is a process which is happening in a which is it is a process which is happening oxygen. So for that, for inert atmosphere to build, generally nitrogen is supplying till date. But now latest trend have seen that CO is for that environment, so that the CO2 captured CO2 from the atmosphere can be utilized and can yield to a zero wastage product. Fourth is the atmospheric temperature. Uh, how is the temperature in which we have kept effects. Next is microbial activity. Microbe activity is encouraged by using more biochar with
Sorry to interrupt. Please wind
Yes,
up
ma'am.
fast.
Okay,
Your
ma'am.
time is over.
Okay, ma'am. These are the characteristics which varies physical, chemical, and characteristics which varies by varying the properties of the biomass. Now, for the scale up of data, there are several disadvantages we are facing. First of all, the availability of biomass. For biomass to be treated, there must be a large availability of biomass, and if that industry is set up outside of any city, so the traveling costs from that ground field to that industry is very high. So there are several drawbacks faced by the biomass. So there is a case study in India, that Organization of Development, Action and Maintenance, Tamil Nadu, has collaborated with Finland to conduct a series of biochar yield in the South Indian. Now, these biochar is mixed with the soil to yield better results, because biochar have their inherent properties which are useful for the soil development. For the now the industrial practice for biomass. Uh, as we all know that sugar industries is a zero waste product. For every product is utilized in some force of this traditional practice co-generation by using baggies as a fuel. These industries can produce electricity and steam for their own requirement. It can also produce significant surplus energy for the sale to the grid using same quantity of baggies. Biomass energy in the context of India. India produces about 450 to 500 million tons of biomass per year. Biomass provided 32% of primary energy use in the country as present. So, as I have already told that the biomass have their own. We are producing biomass in large scales, which till date is getting waste degrading as it is. So get a useful product from that. It's a kind of a zero waste. Ma'am, in my the presentation, it's just a preliminary stage, because to get biomass to an industrial scale up data, there are very factors which are affecting its. Uh, so it's still in the preliminary stage. Uh, these are the references from it.
You're done, Minu?
Yes, ma'am.
I think it was a literature survey, right? Which you have done.
Ma'am, yes, ma'am. We are on
The review.
Yeah.
Okay. So what you have planned on the basis of this? What kind of biomass you are going to take? Can we take the kitchen waste?
Yes, ma'am. We can take kitchen waste, we can take food waste, we can take any biomass which is getting waste, leaf waste, agricultural waste.
I'm
Uh,
talking about kitchen waste, the
yes, ma'am.
vegetable and the fruit.
Yes, ma'am. We
Right.
can take it. Was
So
the only
what kind,
requirement.
yes, what kind of composition is there in these?
Ma'am, same. Kitchen waste contains three waste. Lignin contains, cellulose contains, but the only disadvantages in kitchen waste is they have a high quantity of uh, volatile compounds. So the pre-requirement stage is necessary for that to remove
The
that unbound moisture from that.
the wet, because it is a wet, na,
Very
the moisture,
yes,
the moisture content is there, and the
yes,
pre-treatment requirement, it is always done by the enzymes. Only thing, enzymes, they need a very specific condition. Okay,
ma'am, it's not
so
necessarily require enzyme. Sometimes temperature can act as uh, oven at a particular temperature, but the processing cost is enhanced by it. So we are
when you're
working.
talking about the decomposition of the biomass, like the pyrolysis means the temperature above 500. Okay, so
Okay.
that means the breaking down of the big molecules in the smaller molecules, and that is why you are leading to the bioethanol production. Okay, and
Yes.
bio oil. So the temperature is very high, in a way, right? You are using a temperature, and it is not necessarily the temperature is the only thing which you can use. I think that sometimes you need enzymes also, to remove something else, but they are very
Yes.
sensitive. Okay,
Yes.
Meena, thank you.
Okay, ma'am. Thank you so much.
Next, Prajita,
Yes, ma'am.
please present your work.
Yes, ma'am.
It's my very humble request to please wind up the session within 7 minutes.
Yeah, okay, ma'am.
And the one more thing, please present your work. Just skip the introduction part. Present your work, what you
Oh,
have done.
oh, okay, ma'am. Okay, ma'am. Okay, good evening, everyone. I am Prajita from NIT Patna. I am presenting my work entitled Synthesis and Characterization of Phenoxy-based copper complexes, Structural Feature, Magnetic, Thermal and Redox Properties, and Theoretical Studies. These are my contents. I am skipping the introduction part. So here I have synthesized three polynuclear copper complexes using derivative of salicylaldehyde and one is with the diamine, that is the first complex forming a trinuclear copper complex, and the second complex is a dinuclear copper complex using 5-bromosalicylaldehyde and benzohydride. The third complex is being formed by the 5-bromosalicylaldehyde and 2,2-bipyrimidine. Basically, in the formation of the SIB-based ligand, that is HL1, we have used an in situ reaction mechanism since there is more possibility of formation of a tetradentate ligand in place of a monocondensed ligand. So we have obtained the crystal structure of all the three complexes. The figure 1 shows the ORTIP diagram of the first complex, that is trinuclear complexes. Here, a partial cubane core of trinuclear cation was formed in which there was a two types of bridging. One bridging was with the phenoxy and the second bridging was with the centrally placed hydroxy ion which bridges the three copper ions. Basically, using the addition parameter, we have found that the coordinate, that the geometry around each copper atom is square-based pyramid geometry. Also, the axial copper-oxygen bond was found to be longer compared to the equatorial bond, showing a Jane-Taylor distortion. Here, the figure 2 shows the ORTIP diagram of the second complex where a dinuclear complex was formed. Basically, the geometry around the copper center here is a distorted octahedral where the square base is being formed by the tridentate SIB-based ligand, and at the end position there was one methanol molecule and one methoxy molecule. Here also the axial bond was found to be longer compared to the equatorial bond. This is the crystal structure of a third complex, that is dinuclear copper complex. This complex was directly formed using a 5-bromosalicylaldehyde and 2,2-bipyridimidine. Basically, the perchlorate of iron was found to be attached axially to the each copper atom. Here, the geometry around each copper atom was found to be a square-based pyramid. Some properties were studied. First was their magnetic susceptibility in the function of temperature was being studied in the range of 60 Kelvin to 300 Kelvin. As the temperature decreases, we found that the magnetic susceptibility, the product of magnetic susceptibility and temperature decreases slowly, which shows a weak antiferromagnetic coupling interaction in the copper complexes. Also, the value at the room temperature of chi-T and chi-T was slightly higher than the calculated spin-only value. We have done the cyclic voltammetric analysis to study the electrochemical, sorry, here's some mistakes. Here we have taken the ESR spectrum of the copper complex 1 and 3 to show their polynuclear characteristic. The ESR spectra shows the characteristic of an axial spectrum with a well-defined 4 hyperfine lines in the parallel region due to the interaction of the electronic spin with the nuclear spin of the copper center, suggesting a polynuclear complexes. Through cyclic voltammetric analysis, we have studied the electrochemical properties, and each of the complexes shows a peak in the forward and the backward direction, showing the redox properties of the complexes. Also, the thermal behavior was studied through thermogrammatical analysis, where we have seen that the complex 1 shows the degradation in 2 steps, whereas the copper complex 2 shows the degradation in the 4 step. In the for the complex 1, the first step shows the complete degradation of step-based ligand, where in the third step there was a degradation of the step-based ligand. Also, we have studied the DFT for the all the complexes. Ma'am, just a minute, ma'am. Just a minute. Yeah, sorry for the interruption. Yeah, so we have studied the DFT for all the complexes, and we have the homo-LUMO energy gap for the complexes. As we know that the homo-LUMO energy gap tell us about the chemical stability or chemical reactivity of the complexes. We have found that the energy gap for the complex 1 was least, which shows that the chemical reactivity of the complex 1 was higher than the other two. Next, we have studied the Hillsfield surface analysis, which tell us about the different interaction within the crystal system. Talking about the Hillsfield surface D norm, the red dots show about the strong interactions such as the hydrogen bonding. The whiter patches shows us the weaker interaction, while the blue shows us shows that there is the absence of interactions. Also, through the SAPE index, we can conclude about the interactions such as pi-pi interactions, TH-pi interaction through the triangular blue and red line. These are the 2D fingerprint which shows us the interaction percentage about different interactions. That is, in the complex 1, the highest interaction was between the hydrogen and hydrogen. The next was the oxygen and hydrogen, and then the carbon and hydrogen, that is 15.2%. The same way for the complex 2, there was maximum of 44.6% of interaction between the hydrogen and hydrogen. Lastly, we have seen the interaction energy between the different complexes using the Crystal Explorer software, where here the cube size shows the relative strength of energies. For example, for complex 1, the quantum energy is very less compared to in the complex 2. In the same way, the dispersion energy is greater in complex 1 as compared to complex 2. So in conclusion, I can say that we have successfully synthesized polynuclear copper 2 complexes, that we have done their characterization, studied their structure property relationship, studied their different properties such as electrochemical, thermal and magnetic properties, and through computational methods, we have also studied their different intermolecular interaction and the chemical reactivity. These are the references used. Thank you.
Yes.
Yes, ma'am.
Any question? Prajita,
Yes, ma'am.
you have synthesized complex, right?
Yes, ma'am. Yes, ma'am.
And after that, you have done the molecular docking. What is the
Ma'am.
purpose behind synthesizing these compounds?
Ma'am, we have. Yeah, ma'am.
What is the application of these complexes? What you are going
Ma'am,
to do after?
Yeah, ma'am. Basically, I have synthesized these polynuclear complexes and seen their different properties. Now we are planning to study these compounds for biological activity. In previous works, I have published 2 papers in which I have done molecular docking for the COVID-19 virus. So I am planning to do the same thing here also.
Okay.
Yes, ma'am.
Okay, good work.
Thank you, ma'am.
Next, Jyoti. Can we have Jyoti?
Good evening, everyone. Is it visible?
Better end your slide, Aprajita.
Yes, ma'am. Yes, ma'am. I'm trying.
Good evening, ma'am. Is it visible?
Yes, Beta.
Yes, namaskar. Good evening.
Yeah, you can. Better show your work only.
Yes, ma'am. Ma'am, firstly, I want to thank everyone for giving me this opportunity to present in this international conference on integrative chemical sciences for health and environment. And I also want to thank Deshbandhu College. My work is empowering clean energy through thermoelectric power. The overview of my work includes, I have mentioned the introduction, the limitations of the thermoelectric power, my novelty, the experimental procedure, the results and discussion, the conclusion, the references I have used, and my few publications, and I have acknowledged my teachers who have helped me to continue this experiment. Thermoelectric material is the type of material that helps to generate electricity directly from heat. We use here 2 different thermoelectric materials that are joined at the 2 ends that are known as N side and the P side, means the cathode and the anode. The first thermoelectric material was found in Europe in the early 1800s, and Thomas Seebeck first discovered this Seebeck coefficient, the Seebeck effect. Then Peltier, Jean-Charles and Anthesium Peltier discovered the Peltier.
Sorry, Jyoti, please move to your work, otherwise you will not be able to finish it in 7 minutes.
Yes, ma'am. Yes, ma'am. Thermoelectric materials are really important these days. In fact, NASA also uses this radioisotope thermoelectric generators, and Chandrayaan-3 also used this thermoelectric material in the Vikram lunar lander. The importance of thermoelectric material lies that they are precise control devices, they are compact and solid state. Thermoelectric material generally includes these 3 domains: Seebeck effect, Peltier effect, and the Thomson effect. In my experiment, I have mentioned Seebeck effect, in which directly heat is converted to electricity or electric power. There are a few limitations of the thermoelectric material, which I have tried to overcome. The limitations include that they provide high figure of merit, but not as compared to solar cells and fuel cells. They are relatively expensive to produce. Doping is an important effect in this thermoelectric material, but it is also a challenging process. Seebeck coefficient and thermoelectric figure of merit are important factors that I have used in my experiment. And this is the schematic diagram of my experiment. I have used in the P side and the N side. In the P side, I have used this silver telluride doped reduced graphene oxide. And in the N side, I have used bismuth titan doped reduced graphene oxide. My substrate is fluorine FTO glass. And I have used the heat source from above and cool water in the below from the FTO that I have used as a cold source. The novelty of my work includes we have developed a novel thermoelectric material with higher Seebeck coefficient and lower thermal conductivity and better efficiency at low temperature. And this is the thermoelectric material that I have developed is much lightweight and cheaper compared to all the thermoelectric material that are already present. So my experimental procedure includes, I have taken 2.34 grams of bismuth nitrate pentahydrate and 7.66 grams of titanium. The same composition I have taken for silver and tellurium also. Then I have mixed them together in the mortar and mixed them at and then I have added ethanol at a concentration of 1 milligram per milliliter and made a molar ratio of 1:1. I have used this molar ratio because it has been the best optimization property it has shown and the best Seebeck effect has been shown. I have to make reduced graphene oxide. So for making reduced graphene oxide, I first dissolved graphene oxide in water and then I added hydrazine hydrate as a reducing agent in 1:10 molar ratio at 95 degrees Celsius. Then after that reduced graphene oxide, I have added it as a dopant in both the solution in 1:1 volume ratio and have stirred it for 30 minutes at room temperature. On this fluorine doped tin oxide that I have used as a substrate, I have spin coated P side and N side. Firstly, I have my material, this P side for positive side for silver telluride, I have firstly done spin coating and then covered the P side and then I have done for N side for at 1500 RPM for 10 seconds. And the precursor solution that I have developed, I dried it on the hot plate at 100 degrees Celsius for 10 minutes and this process I have carried out for 6 times. The thermoelectric film that has been formed for both the N and P sides, then I have placed it in a tube furnace under vacuum at 350 degrees Celsius for 1 hour. Then I have done the characterization and the coefficient I have found out using this Ketley electrometer and multimeter also, this Peltier and Seebeck coefficient. And then my thermoelectric material is hence formed. These are the materials and the methods I have used. I have done X-ray diffraction characterization. So this is my X-ray diffraction. This XRD shows the crystallinity analysis and the purity of my synthesized material. This pattern has demonstrated the peak around 25.2 degree that correspond to Miller index of 0.02. And this is shown for BTO doped RGO, means the negative side. I have done this XRD for the negative side and others are still, I haven't got results of the other sample. I've also done IV characterization and the Seebeck coefficient of this IV characterization shows that it generally increases with temperature from 300 to 900 Kelvin. And the thermal conductivity decreases with the increasing temperature. So our material has shown high Seebeck coefficient at 900 Kelvin. It has shown 220 microvolt per Kelvin thermal conductivity for generating clean power. I have also in this thermal generator module, I have shown my module. I have used silver phase as the conducting surface on the conducting surface. So this is my conclusion of my work, that we have developed a new novel technique to fabricate power. The material characterization I have used XRD, and electrical characterization is IV. So our finding produced a new anode and cathode for the thermoelectric material of higher figure of merit and also higher Seebeck coefficient. Our finding also, comparatively to other thermoelectric already present, is much of reduced cost and complexity. These, from here I have taken the references of my work. These are my few publications under my supervisor, Dr. Subhashish Roy. And I really want to acknowledge my mentor and also the head of our department, Dr. Koshi Ganguly of Calcutta University. Thank you.
Jyoti, RGO, is it graphene oxide?
Yes, ma'am, reduced graphene oxide.
Okay. And what else you have taken?
Yes, ma'am, these are my materials. I have taken bismuth nitrate pentahydrate mixed with titanium, and I have doped it in reduced graphene oxide for the cathode negative side. It is for the cathode, and for anode, I have taken silver telluride. That also I have used the same doping agent, reduced graphene oxide.
So have you analyzed the structure of the material you have synthesized?
Yes, ma'am, I have done this XRD character.
Apart from this, the surface morphology of sample. Have you done that?
Yes, ma'am, surface morphology, that sent my sample for SIM, but it hasn't yet, I didn't yet get the result.
So what are you expecting from?
Ma'am, I'm expecting a high Seebeck coefficient from that also.
Okay. Okay, fine. Thank you.
Thank you, ma'am. Thank you.
Next. 45. Nonya.
Yes, ma'am.
Please send your work, Peter.
Okay, ma'am. Hello, ma'am.
Yes.
Is my screen visible?
No, better.
Give me 1 minute, ma'am. Preferences. Share. Hello, ma'am. Is my screen visible now?
Yes, Nonya, it's visible now.
Okay. A very good evening to everyone, respected our chairperson, ma'am, the organizing committee, and all the fellow participants. My name is Ms. Nonya Chimyang from Rajiv Gandhi University, Arunachal Pradesh. The topic of my presentation is unveiling the chemical compounds and drug-like properties of Diacanthus striatus. Diacanthus striatus is a liverwort species belonging to the family Legionnaceae. This is the photoplate of the species showing all the important characters, including its habitat photo, a whole mound of plant body, and 2 different types of leaves. The plant specimen was collected from Tirap district of Arunachal Pradesh. It was then taken back to the laboratory and washed it using tap water followed by distilled water. It was then air dried under room temperature. It was grinded using mortar and pestle, and it was extracted using also GCMS analysis was done at AIRF JNU. The GCMS analysis of methanol extract of the species reports a total of 54 chemical compounds. This is the peaks showing the compounds reported. Out of the 54 compounds, I have selected these 5 compounds, so dependent on the percentage. So these 5 compounds were further subjected for in silico analysis. So during in silico analysis, first we analyze for their physicochemical properties using Swiss ADME software to see if they have drug likeness or not. It was found that all the 5 compounds that I have selected follows Lipinski rule of 5, which confirm their drug-like characteristics. Then using Swiss target prediction software, we predicted the potential targets of the 5 compounds. So this is the potential targets listed here, 15 potential targets, predicted targets that were found using Swiss target prediction software. Then after that, molecular docking analysis shows that the second compound, stigmasterol, and its target compound has the highest binding affinity. This shows that the 15 predicted compounds, I mean the targeted compounds, were mostly belongs to the class nuclear receptor, followed by enzymes and G protein coupled receptor. This is for the first compound. In case of second compound, the 15 targeted proteins were mostly belongs to the class nuclear receptor, followed by cytochrome P450. In case of third compound, the 15 predicted target proteins were mostly belongs to nuclear receptor, followed by cytochrome P450. For fourth compound, the targeted proteins were mostly belongs to the class enzyme, followed by nuclear receptor. In case of fifth compound, the 15 predicted targets were mostly belongs to the class ligand-gated ion channel, followed by G protein coupled receptor. The predicted targets of the compounds were found associated to various pathways. For example, the predicted targets of the first compound were found to be associated with PPAR signaling pathway and neuroactive ligand receptor interactions, etc. The second in case of the second compound, which is stigmasterol, the predicted targets were found to be associated with prolactin signaling pathway, steroid hormone biosynthesis, chemical carcinogenesis, receptor activation, etc. The predicted targets of the third compound were found to be associated with prolactin signaling pathway, chemical carcinogenesis, receptor activation, etc. The predicted target proteins of the fourth compound were found to be associated with chemical carcinogenesis, receptor activation, and other pathways. The predicted targets of the fifth compound were found to be associated with steroid hormone biosynthesis, drug metabolism, etc. The targets were also found to be associated with various diseases. For example, the first compound were found to be associated, the targeted proteins of the first compound were found to be associated with diseases like obesity, inflammation, Crohn disease, etc. The targets of the second compounds were found to be associated with female infertility, subfertility, sterility, and female sterility, etc. The targets of the third compound were found to be associated with diseases like subfertility, sterility, female infertility, etc. The targeted proteins of the fourth compound were found to be associated with hypersensitive disease, insulin sensitivity, insulin resistance, obesity, mental depression, etc. The target proteins of the fifth compound were found to be associated with diseases like obesity, kidney disease, eczema, etc. This figure shows the interaction between the selected compound with their most probable targets. In conclusion, from the previous experiment concluded that the species contain a total of 54 chemical compounds, of which the top 5 compounds together, they occupy a total of about 43% of the total compounds. Using various sophisticated software like Swiss ADME, Swiss Target Prediction, Autodoc Vina, etc., it was found that the compounds have drug-like characteristic. They have targeted they have targeted proteins which are found to be associated with various pathways and diseases. So these results shed light on its possible use as pharmaceutical resource. Further research and experiment should be carried out to explore their full therapeutic potential and to validate their efficacy and safety. Thank you.
Thank you, Nonya.
Thank you, ma'am.
Nonya, I just have a question. Why you are calling it as a targeted protein? Are they proteins actually? As far as I know, these are the secondary metabolites, right?
Yes, ma'am. Yes, ma'am.
And secondary metabolites are proteins. All secondary metabolites are proteins.
No, ma'am.
I think you should, call them something else. I think these are not the targeted. Some different term you should use. I think read it properly. This thing.
Okay, ma'am.
Thank you, Noni. Next, Charu.
Thank you, ma'am. Good evening, ma'am.
Yes. Good evening, Charu. Please be brief in presenting your work.
Ji, ma'am.
Just come straight away to the work which you have done.
Ma'am, is my screen visible?
No, you have not. Yeah, it is coming now. Yes, it is visible. Just skip your introduction part. Come to the synthesize. Dina Khanna. Okay.
Ji, ma'am. I'm
Just
doing PhD under the supervision of Dr. Leena Khanna from Guru Gobind Singh Indraprastha University.
Skip all.
I want here is the indole. Indole is basically
Leave it. Come to the work. What you have done.
these are the naturally occurring indole alkaloids, and these are the some schemes which we have already done it. These are the some phenyldiamine and the phenylglycine. From this, we prepare the Schiff base, and these Schiff base activity also done by the ctDNA and the antioxidant activity. And the second scheme is also done by also these are the ctDNA and antioxidant activity. ctDNA means the Alzheimer's DNA binding ability of compounds was evaluated via ultraviolet visible and fluorescence spectroscopic techniques. Basically, ctDNA is the word combined between the shift-based shift-based or the any complex with the other target DNA. We have to check the how the binding energy, how much and how the good quality of the DNA binding energy is provided. Actually, we take the tryptamine as the indole amine, having the basic frame structure of indole amine. These are the essential metabolite of amino acid. Why we take it? Because these are having the many biological applications like antibacterial, antiviral, anti-inflammatory, and activities. These are also known by the psychoactive substance because of their some hallucinogenic properties. Hallucinogenic properties like which affects the people's or the human mind. These are the some non-tryptamine derivatives which already research published. Our motto is to prepare the shift basis, and these are characterized by the different techniques like nuclear magnetic resonance and mass spectrometry. Next one is the which we prepare shift base. These are also corrected by the molecular docking, in which we take the target and some ligand from both of which are molecular docking, and out of which 12 shift bases, one complex has been shown that in 3D pictures which have the highest binding energy. These are some outcomes like novel heterocycles we have to signified and obtained, and they are used as the medicinal industries. Also, these are the use as a minimal usage and wastage of chemical due to the use of the computational screening. And the major application is we have to prepare the medicinal which have the biological applications, or we have to check the antioxidant activity also. Thank you, ma'am.
Beta, how would you check the antioxidant property of your synthesized compound? You said the tryptamine, right? It is a tryptophan amino acid, tryptamine.
Yes, ma'am.
Okay. The shift bases you have synthesized from that indole derivative. Yes, Beta?
Actually, ma'am, this work is unpublished. Still, we take some aldehydes and some amines from which we prepare the shift bases.
Shift bases you have synthesized now. This is what I'm asking. And after that, you're going to study the antioxidant properties.
Ji, ma'am, antioxidant property and some ctDNA activities.
And what is that antioxidant property? What will you do in that antioxidant property?
Ma'am, in antioxidant activity, I have done already on the H2O2 or the phosphate buffer solution, which we put it in from after that we done the ultraviolet spectroscopy.
Vicky, you are studying the antioxidant property by UV visible spectroscopy. How?
Ma'am, actually, for the UV visible spectroscopy, firstly we prepare the solution of the different concentration of the shift bases, which I got the best binding energy.
From UV visible, you are getting the information about the best binding energy.
No, ma'am. Best binding energy I got from the molecular docking.
Yes, this is what I'm saying. Antioxidant, how will you study the antioxidant property?
Antioxidant from I want to describe कि antioxidant हम एक
Okay, fine, Charu. Thank you. Next.
Thank you.
Are you there, Sarojini? Next. Oral presentation 47.
Yes, ma'am. Good evening, ma'am.
Please present your work paper.
Anji, ma'am. Good evening to everyone. My name is Sajni. I am PhD scholar in Bahamasnath University. My work is study on the long-term durability of biodegradable polymer nanocomposites.
Is it your work or a review?
Review.
Okay.
Yes, ma'am. Now, classification of biodegradable polymer. Biodegradable polymer basically classified into two types, natural and synthetic. Natural biodegradable polymer basically obtained from microorganisms by biotechnology, plants or biomass, animals, and synthetic biopolymers like polyestamide, aliphatic, and aromatic copolyesters. Now, need for improving durability of biodegradable polymer nanocomposites. To produce have weak mechanical and thermal properties, biodegradable polymer nanocomposites can enhance the durability by adding nanoparticles. Degradation behavior of biodegradable polymer nanocomposites affect longevity. Degradation behavior of biodegradable polymer nanocomposites, environmental variable impact. Biodegradable polymer nanocomposite degradation, various degradation mechanisms including enzymatic cleavage, oxidation, and hydrolysis. Nanoparticles added to biodegradable polymer can influence the degradation rate and behavior. The application for biodegradable polymer nanocomposites. They are used for packaging, agriculture, medical, textile, and automotive industries, improve mechanical, thermal, and barrier properties while maintaining eco-friendliness. Now, potential nanofiller for biodegradable polymer. Nanofiller can enhance the mechanical and thermal properties. Consideration of matrix and filler material for renewal and biodegradable nanocomposites. Methods are using for measuring durability performance are different aging process affect polymer material, accelerating aging, studies predict material behavior and assess degradation, various type of aging, including thermal, photooxidative, and water absorption. Thermooxidative aging, heat degradation influence glass transition and crystallization temperature, polymer molar mass reduction occur due to oxidative breakdown at moderate temperature. Antioxidants can slow down the oxidative degradation. Photooxidative aging, UV exposures, nanofiller like TiO to improve UV resistance. Photodegradation can study using UV radiations. Creep and fatigue. Time-dependent deformation is important in long-term application. Nanofiller reduce creep deformation by flattening the elastic components. Friendly models and TTSP can describe creep behavior in biocomposites. Water absorption and hydrothermal aging. Water can alter hydrophilic components in BPN. Nanofiller like carbon nanotube can reduce the water uptake and improve barrier properties. Cellulose nanoviscers slow down the hydrolytic rate constants. Future perspectives are biocomposites made from renewable resources are the material of the future. Durability studies are essential for commercial applications. Biocomposites have great potential in various industries, including engineering and aerospace and medical also. Conclusions are polymer composites play a vital role in structure application. Nanofiller can enhance the durability. Understanding environmental factors and accelerating aging is crucial. Model can help control degradation and improve biopolymer composite stability. Thank you, ma'am.
Okay, thank you. Next. Kitty, Maurya. Are you there, Kitty Maurya?
Yes, ma'am. I'm audible?
Yeah, you are very much audible. Please present your work.
Yes.
Please close your presentation, Sarjini.
So here is my work, and my work is actually in the initial stage. So I have done only the review of literature. Yeah, I'll skip, ma'am. I'll skip this introduction. Yeah. So my topic is the hydrogels as wound dressing materials, and this is a review. As I have gone through many papers, I have seen that a lot of literature is available for hydrogels as using it as wound dressing materials. Since hydrogels, I'll just give you a little bit introduction about the hydrogels. The hydrogels are those, colloidal state, actually those gels which are having three-dimensional structure and in which they have capacity to, they have a high capacity to store the water. Therefore, the name hydrogel is given to them. So here in the review of literature, I have found some of the important properties of the hydrogels as these are biofunctional and bio-inspired biomimetic materials, and these have high viscoelasticity, soft rubbery in nature, and these have high swelling properties, and in fact these are very responsive to different stimuli, and therefore nowadays I have seen that many smart hydrogels, so they have used the word smart hydrogels have appeared, and a lot of research have been done for using such smart hydrogels in different fields. um, so the swelling properties of such hydrogels depends on the water pH, ionic strength, and electric field, light, temperature, etc. And some have self-healing properties also. Wound dressing, we have seen that wound care system, as I have read in the literature, that a wound care system nowadays is actually consuming a lot of finance from the people, since there are two types of wounds. First is the acute and second is the chronic. And when we don't go for the dressing of such wounds, we just ignore the dressings, then such wounds becomes uncurable sometimes, and they can develop the cancers, which brings the financial burden on the people. So wound dressing is very important thing to be done after getting hurt, and different materials are used. In general, we can divide the wound dressing in traditional, biological, and artificial wound dressing. Traditional, we have already seen this such kind of the dressings which we use with the cotton and the cotton inside, and the bandage, like dressing materials are there for the traditional dressing. But the drawback of this traditional dressing, we have found that these are not appropriate for the burns, and sometimes they get adhere to the wound and causes the secondary injury to the wounds. So for biological wound dressing, we have gone through the auto grafting, that is the skins from somewhere. We stick it to the wound, as here it is shown in case of the major accidents. But what is the basic drawback from for this type of the dressing is that to get the skin donors, since these are appropriate for the sometimes for the burn injury also, as well as the accidents, major accidents. But since the wounds are very chronic, we don't get the skin donors, or the part of our body is not like that to use the skin from one side and get grafted to the another side. So we use the artificial or the modern dressing nowadays, and hydrogels are very appropriate for the wound dressing materials. So these are the images for the hydrogels. So main advantage of the hydrogel is that and these are if we see the properties of the hydrogels as the wound dressing material, so these can absorb the water wound. Sometimes what happens is whenever the wound we get hurt, the wound releases some kind of the fluid which they can able to absorb and maintain the moist environment. Also gaseous sections are also possible through it. Sometimes we impregnate these hydrogels with some of the nanoparticles also, which have antibacterial properties, and these are easy to remove, so they cannot cause the secondary injuries, painless and easy to handle. And these have biomechanic and bioelastic property. These are simple and reliable sterilization method. These have some, these are sterile actually. So there are some stimuli responsive hydrogels also, um, which are photo responsive, thermo responsive, pH responsive, glucose and reactive oxygen species responsive. Details I have not included over here. And so these are my conclusion. Sorry. These are my conclusion that hydrogels are good dressing materials, and the healing times of wound can be effectively reduced if we use such kind of the materials. These are skin mimic also. These can cure the wound in the natural manner. If we impregnate such nanoparticles, and the healing time will also decrease. And these are actually excellent dressing material, but some modifications are needed so that they can become cost effective. And also I have not included over here, for sorry for this, a secondary material, a secondary thing is also required for the adhering such kind of the hydrogels sometimes. So some modifications are required so they get, so that they get easily adhere to the wounds. Thank you, ma'am.
Have you planned something?
Actually, my guide has given me some of the chemicals, a lot of polymers she has considered, like PVA and 5 polymers I don't know for
polyvinyl
alcohol. Yeah.
alcohol. Okay,
Yeah,
polyvinyl
and
alcohol.
she said, and then cross-linking material will be gelatin,
Okay.
and will going to impregnate such this hydrogel with other particles also, like she has suggested me silver nanoparticles, zinc, copper, and many others, and then go for the comparative study and see what is there and what is the difference, and actually which is the excellent wound material in between this.
Okay, thank you.
Okay, thank you.
Next, Natasha. Can we have Natasha, please?
Yes, ma'am. Good evening, ma'am.
Good evening, beta.
Ma'am, is screen visible?
Screen is there, but your presentation is, yes, now it is visible.
Good evening, everyone. My name is Natasha. I am doing PhD under the supervision of Dr. Arun Kumar Singh. And the topic of my presentation is biomaterial-based coating for antibacterial applications. So this is the content. I'm skipping it.
Skip, yes.
So bio-based material like this is the chitosan structure here. And if we use bio-based material for coating the surface, this is the green one is live bacteria and red one is dead bacteria. So bio-based, with the help of bio-based material, antibacterial coating can be created. So starting with the very basic, hydrophobic, anything that repels water, because they are non-polar molecule, are described with the adjective hydrophobic. So what are super hydrophobic surface? So the surface that repels water are called as super hydrophobic surfaces, but the condition here is the contact angle should be greater than 150 degree. The value of the contact angle should be greater than 150 degree for any surface to be a super hydrophobic. And to make any surface super hydrophobic, we need low surface energy, high surface roughness. So contact angle is the angle which is formed here, gaseous phase, solid phase, and liquid phase, where they intersect. This angle is called as a contact angle. And for if its value is greater than 150 degree, it is called as super hydrophobic. So is there any relationship between contact angle and wettability? So if the value of this contact angle is less than 90, then surface is hydrophilic, water loving. If the value is greater than 90 degree, then it is hydrophobic. But if it is greater than 150 degree, it is super hydrophobic. So with the help of such kind of materials, coating have been created, which can be done on the fabric. Here it is a cotton fabric. It can be done on any surface, for example, wood, PU sponge. Such kind of coatings which are created from super hydrophobic material can place a very important role in the antibacterial application. So super hydrophobicity is present in the nature everywhere. For example, in the butterfly wings, water strider legs, peanut leaf. this red rose petal. The water is forming here beads on the surface of a red rose petal, indicating that the leaf surface is super hydrophobic. Lotus leaf, poplar leaf, fish scale. These are all the examples of super hydrophobicity in nature. So there are various applications of super hydrophobic coating. It can be used in anti-corrosion, anti-fouling, oil water separation, self-cleaning, antimicrobial, antibacterial, drag reduction, and anti-icing. These are the various applications of super hydrophobic coating. So what are the drawbacks behind the conventional coating? The conventional coating, in which various fluorinated compound has been used in the various studies, it affects human health. It can cause eye irritation to skin. So short time exposure can affect IQ. So these are the various effects of the coating, which such kind of coating that repels water with chemicals. So in order to avoid these drawbacks, the motivation is towards bio-based material, so that we can minimize or prevent the various environmental effects, or expensive chemical cost can be reduced, or toxic byproducts can be reduced. So the bio-based material, like here is peanut shells, waste eggshell. So with the help of bio-based material, super hydrophobic coating can be created, which has various application in other fields, like we have seen in the previous slide. It can also be used in antibacterial application. So there is a study by Lee et al. In which ammonium polyphosphate carboxymethyl cellulose, or graphene, has been used to form a eco-friendly and multifunctional super hydrophobic coating. There is another study in which chitosan can be found in crab shell. It is also a kind of waste. Chitosan can be used to create such kind of coating. In this case, another chemical like benzophenone 3, all these are used to create a coating which show antibacterial property both for gram-positive and gram-negative bacteria. There is another study in which the antibacterial coating has been used by the use of chitosan and phytic acid. Both chitosan is bio-based, chitosan and phytic acid has been used to create a coating which shows antibacterial property and oil water separation. So in this presentation, I have given views regarding the use of various bio-based material to create the coating which can do antibacterial application, and with the help of this green eco-friendly super hydrophobic nano coating, it has potential application in different field. So the further study should be concentrated on creating low cost environmental friendly bio-based super hydrophobic coating that has application in everyday life. Thank you, ma'am.
Please, Kitty, mute yourself. Okay, thank you, beta. Next, Surjit.
Good evening, ma'am.
Yes.
Yes,
whose mic is on?
आप ही खाओ उसको.
Kitty Maurya. Parush. Can you mute her? Yes, start.
Good evening to all of you. Myself Surjit Kaur. I am doing PhD under the supervision of Dr. Mithu Mete Jana from Sant Baba Bhag Singh University, Jalandhar, Punjab. Now I am going to represent my topic, graft copolymerization of ethyl methacrylate onto mercerized yucca filamentosa using FAS and KPS as a redox initiator in air. This is
Welcome to the work.
Okay. I'm skipping the part of introduction. So this is a yucca filamentosa.
Not visible, beta. Just click on the
that
slide.
I am working on.
Beta, click on
Yes,
the slide.
ma'am.
Click on the slide which you want to present. I think
Okay,
there are
ma'am.
so many slides, the 35 slides. Just come straight away to your work. Yeah, please.
Okay, ma'am. Is my screen visible, ma'am?
Yes, yes.
This is the yucca filamentosa plant that I am working on it. History of is a traveling plant in the Asparagus family, grown mostly to the southern United States, but it also available in India, China, and other European countries. Yucca filamentosas leaves are smooth, leathery, and evergreen, growing in a spiral rosette pattern, and that give the yucca tropical palm tree appearance. Fiber is obtained from themselves. So after reviewing the literature, it is observed that vinyl monomer graft polymerization onto the mercerized yucca filamentosas fiber has not yet been done. So due to this, it was decided that it would be beneficial to graft co-polymerize ethyl methacrylate onto the mercerized yucca filamentosas, utilizing ferrous ammonium sulfate and potassium persulfate as a redox initiator, and analyze its various physicochemical and morphological characteristics. Research methodology. Investigation required a specific chemicals, which were potassium persulfate, ferrous ammonium sulfate, ethyl methacrylate, distilled water, yucca filamentosas fiber, sulfuric acid, sodium hydroxide. And the equipment necessary for the investigation were electronic balance, thermostatic water bath, hot air oven, thermometer. Research methodology. Masterization of yucca fiber. Yucca fiber was first purified for 72 hours by soaking in acetone. Then yucca fiber was soaked in 10% sodium hydroxide solution for 30 minutes, and then immerse the sample in 1% sulfuric acid solution for 5 minutes. Then it was removed and rinsed with distilled water till acid free from fibers. The last washing was done with slightly alkaline softener to neutralize the rest of acid, and then be allowed to dry in oven at 40 degrees Celsius. Then mercerized yucca filamentosas fiber was synthesized by using ethyl methacrylate as a principal monomer in the presence of air. Graft copolymerization of mercerized yucca filamentosas fiber with principal monomer in air. In order to activate mercerized yucca filamentosas fiber at room temperature, it was immersed in 100 ml of distilled water for 20 hours before graft copolymerization. A particular molar ratio of ferrous ammonium sulfate and potassium persulfate initiator was added to the reaction flask, while in the reaction mixture was constantly stirred. The principal monomer was then introduced gradually drop by drop. At a specific temperature and time, the reaction takes place. The homopolymer was eliminated using acetone flux, and the graft copolymer was then dried at 50 degrees Celsius as per ASTM standard until it acquired a consistent weight. The following method were used to calculate the percentage of polymer loading, percentage grafting yield, percentage graft efficiency, and percentage homopolymer formation.
This is directly to your time is already over.
Okay. Okay, ma'am. Okay, this is the overall flow of work. Mechanism. The standard method used to mercerize the C2C3 C6 hydroxyl of yucca filamentosas. The active sites for the development of polymeric chain by grafting into mercerized yucca filamentosas include C2, C3, and C6 ester and CH group. Ferrous and KPS combine to produce a SO4 radical ion. The synthesis of graft copolymer as well as the homopolymer is caused by the interaction of SO4 and water with the produced OH radical and is responsible for the further chain propagation. So optimization of various reaction is followed by graft copolymerization of mercerized yucca filamentosas fiber with principal monomer in air. The percentage of polymer loading, graft yield percentage grafting efficiency, and homopolymer formation was determined by using the trend method. This table present the evaluation optimization parameter for grafting EMA onto the mercerized yucca filamentosas in air. You can see in this table the percentage graft yield is increased as we optimize the different reaction parameter. This is the optimized conditions for synthesis of graft copolymer onto the mercerized yucca filamentosas fiber. The time is 120 minutes, temperature 45 degrees Celsius, solvent 125 ml, pH 7.0, molar ratio of initiator that is FAN KPS 1:0.50, and ethyl methacrylate that is the principal monomer 3 ml. The impact of reaction time on the percentage of graft yield can be observed in figure 1. As the reaction time increases, it is evident from the figure that the percentage graft yield progressively increased until it reached its higher value, that is 66.8% in 120 minutes before starting to decline. It is believed that interaction between SO4 and the backbone of muscular eucalyptosa developed with time might be responsible for the increase in graft yield over time. The graft yield percentage may be decreased as a result of poly-AMA chain on the backbone polymer deteriorating after the optimal reaction time. The reaction temperature has found to have a key role in achieving the highest graft yield. The reaction temperature was varied from 35 to 60 degrees Celsius, while other reaction parameters remain constant in order to study the impact of temperature. It has been observed that the temperature above the optimum caused a reduction in graft yield. Muscular eucalyptosa OH group and SO4 reacted slowly with each other at low temperature and producing a few macro radicals as a result, and percentage graft yields were constantly decreased. Impact of solvent. Figure 3 clearly shows that the graft yield increase as solvent volume is increased. The percentage of grafting decreases when the solvent volume is rises after reaching the optimal level, that is 125 ml. With the development of homopolymer, the reaction mixture initial viscosity gradually increases. The increases viscosity of the medium generate a barrier that prevent the free radical ions from getting to the active site. On the other hand, exceeding the optimal solvent volume led to decreased graft yield. A decrease in concentration of SO4 and OH radical free radical may be cause of this. The impact of pH of the reaction medium is crucial to the grafting technique. At pH 7.0, the highest grafting, that is 87.6% has been observed. Graft yield decline and pH continue to decrease or increase, and this might be a result of premature polymerization termination brought on by pH increase. So various smaller ratio of ferrous, ammonium sulfate, and potassium persulfate were used throughout the graft co-polymerization process. The specific ratio of FAS and KPS had a substantial impact on the graft production. Initial observation showed that the percentage of graft yield increased and with increasing molar ratio, but once a critical ratio was, that is 1:0.5, the increasing molar ratio continued to decrease, and this might be a result of ferrous initially being oxidized to ferrous 3 positive upon interacting with KPS and producing increasing amount of SO4 radical, and which start the grafting reaction by producing free radical site on muscular eucalyptosa. Last one is impact of concentration of monomer. Figure 6 illustrates the effect of EMA concentration on the development of graft copolymer. As the EMA concentration increased, the percent graft will increase steadily until it reached its a higher value, that is 129% at 3 moles per liter. The graft yield decrease as the concentration of monomer increase further. This phenomena might be clarified through the fact that increase in concentration of monomer causes a buildup of monomer radicals and that are free along the backbone, and which then promote the development of graft copolymerization. Above the optimal concentration of monomer, the primary radical, rather than acting with the polymer backbone, attack the monomer, which result in the homopolymerization process and reduce the graft production. Conclusion. In order to obtain the desired properties such as moisture, chemical, solvent resistance, as well as higher thermal deposition that could be incorporated into the backbone, it is important to synthesize graft copolymer of muscular eucalyptosa with ethyl methacrylate in the presence of air. Graft copolymerization is muscular eucalyptosa fiber to increase surface area and for further reaction as well as decrease water and moisture absorption. The maximum graft yield was achieved by optimizing different types of reaction parameters, including reaction duration, reaction time, temperature, solvent, pH, molar ratio of initiator, and concentration of monomer. This paper explains how eucalyptosa fiber is graft copolymerized and muscular during the synthetic test, and how different reaction parameters affect the graft yield when they are optimized. Thank you.
Yes, Beta.
Yes, ma'am.
I just want to know what is the principal monomer?
Yes, that is ethyl methacrylate.
methyl acrylate. Okay. You have grafted your fiber on that.
Yes, ma'am. Yes.
Okay. So have you published this work?
Yes, ma'am.
Have you published, or you are still in the process of publishing?
Not, ma'am. It is not published. It is a process of publication.
Okay. Thank you.
Yes, ma'am. Thank you.
You can end your presentation.
शांत हो जाओ, शांत हो जाओ.
Ma'am, can we move to the end of the session?
Yeah, this is close, but I just want to say a few things. The session has been very enriching, and I have seen a few presentations were damn good, and some of you are doing a commendable work, and in your future definitely would be at a good place. And I would like to thank Dr. Archana and Mr. Porush for coordinating this session so well. And I'm grateful to the convener of this conference, Dr. Pratima, who is a good friend of mine, and she is such a dedicated and hardworking person. And thank you all. Thanks to the organizer and the participants. Very well done. I think we should end this, and I'll mail the evaluation sheet. Archana.
Okay.